we're going to be looking at this week has to do with volumes of revolution once again, but instead of a solid one, now they're actually going to be hollow. So instead of using what are discs or plates, now we're going to be using washers. Basically, it's a plate minus a center, so it's a hollow plate. So the discs have holes in the center. So now instead of discs, if I could spell instead, there we go. Instead of discs, we're going to use washers. So these are hollow. Okay, so really all it is, it's this part, the same old disc, but the center's been hollowed out, right? It's been erased out, it's been removed. Boom. Hang on, is that the way you spell discs? Hang on. Discs, that's better, right? Actually, I think one's an American no, it's not an American versus a Canadian or a British thing. Hang on, I think there's more than one. There we go. Discs. There we go. That's even better. So how do you do the area? Remember we used pi r squared before. Well, now we're not dealing with one radius. Now we're dealing with two, right? So we've got r1, you've got the big radius, and you've got r2, you've got the small radius. And if you think about it, the area here is pi, the bigger one, r1 squared, minus pi r2 squared. So really the area is going to be, think of it this way, pi, you can factor out the pi. So it's r1 squared minus r2 squared. So it's going to be the bigger one squared minus the smaller one. That completely makes sense. Yeah, so the bigger one. So if you think about it as functions, what did we do before for volume? Well, we had pi and then f of x squared dx, right? But hang on, it's not just going to be that simple. Now it's going to be a function squared minus another. So we need to determine which is the inside and the outside, so the bigger and the smaller. So based upon the center of where this thing's being spun around. So we're going to call this the outside function. Minus the inside function. Squared. And yeah, if I'm going to be spinning around dx in this direction, right, then it's going to be dx. So just like the areas in between curves, it's a difference. However, now it's square. Now it is squared. Okay, so if I end up getting an answer that's negative, I know that I just had these two backwards, right? So I got the right answer, but if I get like negative 18, well then it should be positive 18 because you can't have a negative volume. It just means that I had these two backwards. And you know what, then if you really wanted to, instead of redoing the whole question, you just do the absolute value, done, right? Because I know that's the difference. Okay, so let's take this region here. So this is 4 minus x, this is 2. This is the region I'm going to talk about, right? This little triangle. So I'm going to take this and we're going to spin it around the x-axis. So it's going to go in that direction, if you think about it. So that's going to go down to here. You're going to get a mirrored image. What is this thing going to look like? Now, I could kind of draw it over top, but it's going to make a bit of a mess, right? If I get a mirrored image, oh, that's terrible. Absolutely terrible. And then it's going to be kind of round like this, if you think about it. And then behind. So that's what this thing's going to look like. Hang on. See if I can redraw it over here. Draw it freehand. So notice, even though it looks like an oval, right? It is circular. That's just the perspective. And it's hollow. So there's the base. And here's the outside. So this thing is hollow in the center. It's going to be a shape kind of like this. So I can see the base here, and yeah, I can see it's getting thinner and thinner and thinner, and then this is going to be, so this is kind of like a volcano. If you turn your head sideways, it's kind of like a volcano that's been hollowed out. Because this was a straight line, this is going to be a cone, right? Or part of a truncated cone. A cone, if it went on forever, but truncated means it's been chopped off. Boop. That's what truncated means. Okay, so here's the thing. I don't know any of these numbers, do I? No, I don't. Okay, so let's get rid of this because this is come on, come back. Come on back. There we go. Let's get rid of this because I've just kind of made a mess out of this. I need to know a few numbers here. I need to know my x interval. So I know it's going from 0 to where? They didn't tell me the interval. However, I do know that this is 4 minus x and this is 2. So where does, right? Where does 4 minus x, where is it going to actually equal to 2? Yeah, when the x value is 2, right? So I know that this has got to be 2. There we go. That's easier. So sometimes you might have to solve a simple equation, but now I know it. I can see from the diagram it starts at 0 and it's going to go to 2. So let's set this thing up. Volume is going to be pi integral from 0 to 2, left to right, and I want this to be dx. So it's going to be the outside function squared minus the inside function squared, okay? So here's the thing. What's the outside function? Well, what's the axis of rotation, right? It's spinning around the x-axis. So the outside function is from the axis all the way up to here. This is the outside function. And you know what? Let's do this in a different color. Let's do this one in red. So the outside function is the distance from here all the way up to here, okay? And that is this function. This is 4 minus x. So this is going to be 4 minus x squared. That's the outside function. What's the inside function? The hollow part, right? This part that's not really there. That's the distance from here to here. Now, it's a flat line. Yeah, so as I'm going from left to right, it's just always a constant height of 2, 2, 2, 2, 2, 2. So this is just a constant 2. That's what this is. So it's the outside function squared minus the inside function. And the inside function is just a constant height of 2 because it's always 2. So that's why this is a perfect cylinder this would be easy to figure out the volume of if I had to figure out the volume, right? But I'm doing this as an integral. Okay, so now I can actually go back and let's do it. Pi, the integral from 0 to 2, I know this is going to be 16 minus 8x plus x squared, right? Minus x being squared, minus 4 dx. That's a pretty straightforward one. Okay, yeah, I can actually do this by hand. It's going to be fun. Yay! What do we got? X squared plus 8x plus 12 minus 8x. Silly. Yeah, silly little mistakes. That's what kills me. Okay, so pi, and then what do we got? So we get x cubed over 3 minus 4x squared plus 12x. You're really plugging in 2 and 0, right? So if I plug in 2, I'm going to get 8 over 3. I'm going to get 4 times 4 is 16 and 24. I think this turns out to be 32 thirds times pi. Okay, so that's an exact answer. Big deal. We could also go right from here, simplify it down, go to your calculator, right? We know it's just going to be a number. This is a definite integral, right? Doing the antiderivative, we did that earlier on in like January and February when we were first starting antiderivatives. I know how to do the power rule, right? But there it is. Okay, so that's going to be the area of that one. Or no, not the area, the volume. Okay, one more. Let's try this one. Rotate this area around the y-axis. So it's going to be spinning in this direction, not vertically, in this direction. Okay. Rotate this area. Well, I'm going to say it's in the hang on, what do we got? I'm missing some of the stuff. This should be x is equal to 1, y is equal to 1, and here's the other function. Y is equal to 4 over x. Okay? That is a curve. Okay, x is equal to 1, y equal to 1. These are straight horizontal and vertical lines. So I'm going to take this region and spin it. Okay, so let's do a quick little diagram of this thing. Oh, that's not good. I can straighten that out. X equal to 1 is right there. Y is equal to 1 is right there. horizontal line and vertical line. 4 over x. Well, hang on. When the x value is 1, the y value is 4. When the y value is 1, the x value is 4. When the x value is 2, the y value, oh yeah, remember this was a curve. This is an oh yeah, it's a 1 over x kind of curve. So it's a curve that does this, asymptotic in that direction and that direction. But this is the little region we're talking about. It's bounded by these 3 graphs. So one line, the other line. So this is really this region that we're talking about. It's kind of like a triangle. However, it's got 2 flat sides and it's got 1 curved side. So it's not truly a triangle. Triangle is 3 straight sides. So that is the region. Okay, and we're going to be spinning it around the y-axis. So in other words, it's going to go in that direction. I'm going to get a mirrored image over here. I'm going to get something like that. And this thing is going to look, oh yeah, kind of like a tree stump. It's been hollowed out. It's going to look something like that. Okay, I've made a mess out of this thing. Let's see if I can redraw it over here, though. Okay, get rid of this, get rid of this, get rid of this. Yeah, just making a mess. However, I do know it's going to be going in that direction. So, I know it's going to be hollow. How come? Because it's not, see this region here? It's not actually touching the axis of rotation. The axis of rotation where it's spinning around, it's not touching, so I'm going to get this hollow spot in between here and here, right? So there's the axis of rotation. If you think about it down the center, this thing is going to curve out in both directions. Oh, it's terrible. And then kind of circular. And this should be, because that's a straight line going down, it should look something like this. Okay, so it's, yeah, kind of like, well, once again, like a volcano or a tree stump, because it's actually going to be a curve. The other one was straight lines, right? This one's going to be a curve. Okay, so it's still a volume. Okay, so here's my problem. I need to have things as a function of y. So in other words, I need x equals a function of y. We need to solve for x. Not a problem. I can multiply up the x and divide down the y. I'm going to get x is equal to 4 over y. Yeah, that's right. Because remember, if I was to multiply this up, this is like saying the equation xy is equal to 4. I don't care about the order. You can divide the 4 over, you can divide, well, either one. X times y, I can divide the x down or the y down, right? Either one. Doesn't really matter. Let's bring that back. So this is the exact same as this. Now, what is that? X is equal to 4 over y. Is that the height under the curve? No, it's the height from here out to the curve. Okay. So I need to be thinking about, because I'm going around dy, I need to be not the height under. This is the height under. It's from the y-axis over. Okay, so let's start here. The outside. Here's the axis of rotation. So the outside is going to go from there to there, right? That's the outside. And that is this distance here, 4 over y. What about the inside one? Well, the inside is from here to here, here to here. Oh, and it's just a constant 1, right? It's just 1, 1, 1. It's because it's a straight line, vertical line, this is just a constant 1. So let's set this thing up. What is the volume? I know it starts with a pi because these things are circular in nature. And I know it's dy. So is this from 0 to 4? No, no, no. Hang on, it's dy. So I'm not going from 0 up. It doesn't start at 0. It starts at 1. So from 1 up to 4. So this is from 1 to 4. It's really easy to say from 0 to 4, but we're not dealing with any area here. No, no. This is where the area starts. So that's why a diagram for these things is so incredibly important. This is not a fantastic diagram, but it shows me, okay, I know the direction we're going in, right? Okay, so the outside function is going to be from here all the way up to here. It's 4 minus y. That's the height under the function if you think about it in the y direction. Okay, so come on back. So this function squared. So 4 over y squared minus, now the inside function is just from here to here, it's just 1. So it's just always constantly 1, and it's squared. Why are they squared? Remember, because it was pi r squared minus r squared, so outside squared minus inside squared. Okay, so now we can just do it. 1 to 4, this is 16y to the negative 2 minus 1 dy. Yes, I can plug this into a calculator. However, this isn't that hard to do, right? Remember, this becomes y to the negative 1, increase the power, and then divide by that number. So it's negative 16 minus 1y. Hang on, does that make sense? Quickly do the derivative. Positive 16y to the negative 2. Yes, it does work. So now I'm actually going to be plugging in, but I'm plugging in 1. So it's not just all zeros at this point. Okay, well, let's say this was a question that you had without a calculator. Let's do it. So what do I got? I got negative 16 times 1/4, right? That's what 4 to the negative 1 is. Oh, minus 1y. So minus 4, right? That's the first part. Subtract off 1's being plugged in. Negative 16 minus 1. Okay, so whatever this is, what am I going to get? So this is going to be negative 4 minus 4. This is going to be negative 8. Subtract. No, let's just make that plus. Plus 16 plus 1. So negative 8 plus 16 is positive 8 plus 1. This is going to be 9 pi as the exact value. Okay, so these two questions were from the previous one, I think from the original assignment. I think we skipped over those ones, but basically these are just the outside squared minus the inside squared. So it's going to be one function minus the other one. These ones, I think I've got all these ones on the website as well. These ones, you can plug them into a calculator, and if you get it backwards, you're going to get a negative volume. But that doesn't mean you did it wrong. It just means you got the two functions backwards. So you can switch it and turn it into a positive volume by doing an absolute value. Alrighty, good luck with these.